Hi guys, today we're looking at graphing the absolute value. Your learning intention for today is by the end of this lesson you'll be able to graph the absolute value and then solve for the value of x. Okay, let's look at the question. Using the same axes and scales, graph the functions where f of x is equal to the absolute value of x plus 1 and g of x is equal to 3. Then use your graphs to find the value of x for which the absolute value of x plus 1 equals 3. Okay, let's graph it first. To graph, the first thing we need to do is plot the points for f of x is equal to the absolute value of x plus 1. Drawn out our table and given ourselves the values of x is equal to -4 to 4, so our domain, I've decided my domain is between -4 and 4. Okay, so this gives us our x values of -4, -3, -2, -1, 0, 1, 2, 3, and 4. Substituting our values of x into our function, the absolute value of x plus 1 gives us our y values. You can also use the function button in your calculator to solve for these values of y. And from here we're going to graph both of our functions on the same axis. So we have our function f of x is equal to the absolute value of x plus 1, and then g of x is equal to 3. So this means that y is always equal to 3 here. This will be a horizontal line at y is equal to 3. So drawing our two graphs, we get this. We can see from this that our absolute value function will only ever have positive values. So the graph will form a V shape. So all absolute values will form a V shape when graphed. You should also note that the graph is symmetrical about this translation. Okay, so x minus 1. Okay, so your graph is symmetrical about the translation on the x-axis. All right, now that I have both of my graphs drawn, I read the points of intersection. So my first point of intersection I can see is here, which is -4 on the x-axis and 3 on the y-axis. And my second point is 2 on the x and again 3 on the y. Please pause this video and take down this example. Okay, let's try another question. We're asked to find two values such that the absolute value of 3b plus 5 is equal to 17. In this case, I can do this in two separate ways. I can A, graph this function and solve for the value of x when y is equal to 17, or I can do it algebraically like we had in our last video. So let's graph it first. So here is the graph of my function, using my calculator to get my values or substituting in my values for x. I want to see what is the value of b or x when y is equal to 17. So we draw a horizontal line at 17 and then we read down to find our two values of x. The other way to solve for this is to solve algebraically. So we can either solve for the value of x that gives plus and minus 17. This gives us 3b plus 5 equals 17, or 3b plus 5 equals minus 17. Solving for b gives us 3b is equal to 17 minus 5. 3b is equal to 12, and therefore b is equal to 4. Or 3b plus 5 equals 17, and 3b equals minus 17 minus 5, which gives us 3b is equal to minus 22, and b is equal to minus 7 over and 1/3, or 7.33. We can see that both of these values are the same as we would have found using our graph. Our other way to find the values of b is to square both sides of your equation, which removes the modulus notation, and solve from there. This gives us 3b plus 5 squared equals 17 squared. Expanding this, we get 9b squared plus 30b plus 25 equals 289. Bringing the 289 to the other side of the equation leaves us with 9b squared plus 3b plus 25 minus 289 equals 0. Grouping together our like terms, and we get 9b squared plus 30b minus 264 equals 0. Then we want to solve for b, so the first thing we're going to do before we factorize is divide by our common value to make it a bit easier for us. So all of these values are divisible by 3, so I'm going to divide everything by 3. And I get 3b squared plus 10b minus 88. And factorizing now, so we're looking for the factors of 3b squared, which are 3b and 1b, and the factors of 88, which will give us 10. So our factors of 3b squared we're going to use are 3b and 1b, and then our factors of 88 are 22 and 4. And we can always check if we're right by using our smiley face method, which means that you find the product of your factors and see if they add together to give you the middle number. So 22 times b gives us 22b. 3b minus 4 gives me minus 12b. This leaves me with 10b, which is the same as our middle value. Okay, now that I have found my factors, I need to solve for b by putting both equations equal to 0. This leaves us with 3b is equal to minus 22, and 1b is equal to 4. Solving for b, I divide by 3, and I get b is equal to minus 7.3, the same as we found in our other two methods. Let's look at another example. So reminding ourselves that the modulus of a number is the non-negative value of the number. Here we're asked to solve for 3 times the absolute value of x plus 1 minus x plus 5. In this case, if you have two absolute values in your equation, you must isolate one of the absolute values before you solve. This means that you need to have your equation with one modulus on one side of the equation and one modulus on the other side of the equation. This leaves us with 3 times the absolute value of x plus 1 equals x plus 5. From here, to solve for our values of x, we must square both sides of the equation to remove the modulus notation. This leaves us with 3 squared, which gives us 9, times x plus 1 squared equals x plus 5 squared. We now expand our brackets. This gives us 9 times x squared plus 2x plus 1 equals x squared plus 10x plus 25. Multiplying in our 9 on our left-hand side, and we're left with 9x squared plus 18x plus 9 equals x squared plus 10x plus 25. Bring everything to one side of the equation, and we're left with 9x squared plus 18x plus 9 minus x squared minus 10x minus 25 equals 0. Grouping together our like terms, and we have 8x squared plus 8x minus 16. From here, you want to factorize your equation to find your values of x, but just like in our other example, I'm first going to simplify my equation by dividing everything by the common factor. So here, everything is divisible by 8, so I'm going to divide each of my terms by 8 to make my factorizing a bit easier. This simplifies to x squared plus x minus 2 equals 0. And factorizing this gives us And factorizing this gives us x minus 1 and x plus 2. Solving it, we're left with x is equal to 1 and x is equal to minus 2. Okay, we find our values of x. Let's look at our second method in which we can solve for this. Our other way to solve for our values of x is using our graphical method. We plot f of x is equal to 3 times x plus 1 and g of x is equal to x plus 5. So we take each of our functions, 3 times x plus 1 and the absolute value of x plus 5, and plot these separately. Finding our points using our calculator and graphing them gives us the following two functions. From here, we find the points of intersection on our graph. So we can see that our points of intersection are here and here. Reading the value of both gives us minus 2 on the x-axis and 3 on the y, and 1 on the x-axis and 6 on the y. Therefore, our values of x are minus 2 and 1.